So, good morning, everyone. Welcome to our 10th short online conference. It's a beautiful day today here in Vienna. I hope that it's the same by you and you will enjoy spending the next hour with us. So, today is the opportunity for Bas to introduce our speakers. So, Bas, the floor is yours.
Yeah, thank you, Natalia. So for the regular attenders of the short online conference, it's not Anna doing the introduction of the speakers anymore. I will take over from her, so I have big shoes to fill, but I will do my best. So for today, we have two very interesting speakers centered a bit around the theme of personal weather stations. And we will start with the presentation of Arjan Droste, who will present on Delft Measures, the assessment of citizen science rainfall observations. And Dr. Arjan Droste is an assistant professor here in the urban climate at TU Delft. He obtained his PhD in 2020, actually with a dissertation entitled Understanding the Urban Atmosphere Through Conceptual Modeling and Opportunistic Sensing, in which he already made use of both CML and PWS data. And now at TU Delft, he currently leads the Cooling Cities flagship, part of TU Delft's climate action program. And as such, his research also largely focuses on understanding and describing the urban climate across different scales. And I think part of that he will share with us today. So Arjan, thank you for being here, and the floor is yours.
Yeah, thanks, Bas, for giving me the opportunity to present something about the work that we do. You should be able to see the slides. If not, say something.
Yeah, we see.
Yeah, that's great, wonderful. Then we'll get started. So it might be a nice day in Vienna, but here in Delft, it's very rainy, which I think is a opportunity to then talk about personal weather stations and specifically rainfall observations from personal weather stations, which is of course what this OpenSense cost action group focuses on. So I'll be talking about the citizen science project that we have running in Delft for a couple of years already. It's called Delft Measures. In Dutch, Delft meets, because it's also a way for citizen scientists to meet each other and get interest in science. It's not only my work, it's mostly the work of Marchien Boonstra, which you see here in this very nice action shot of doing a measurement of rainfall, the garden hose. It was her MSc thesis that basically I will be showing a couple of things of and a few others. So to give some context, the Delft Measures Citizen Science Project, really trying to measure the urban climate in Delft in the Netherlands, which is a small city between Rotterdam and The Hague, and where our university is located. This project started in about 2021, first with manual rain gauges, and then we noticed that we did not get any measurements during summer holidays because people did not want to get out of bed or were just simply away. So we quickly moved over to a personal weather station, which you see here on the right, the Alecto WS5500, which is a very low-cost station. It's about 200 euros, measuring rainfall, wind, temperature, and humidity. And on some occasions, we also have soil moisture sensors. This obviously lets us research the urban climate in very small detail, because typical weather observations for cities are just absent, or we need to do expensive campaigns. So personal weather stations in general are a great opportunity to learn more about the urban climate. But this is not just like a crowdsourced pool from NetAtmo or something similar, because we have interactions with these citizen scientists. So we got thinking, how can we benefit from that citizen input for our understanding of the hydrometeorology of the data quality? Because this is one of the big problems, I'm sure you're probably aware of personal weather stations, that we simply don't know where they are and how they are installed. And now we can visit these people and see how it is. This is a somewhat older picture there showing where the stations are. We really spread them across the different urban local climate zones, the microclimates in Delft. We have more now, about 50 to 55, including a whole bunch on campus here. So what I mentioned before, probably preaching to the choir in this case, is that there is, of course, a lot of uncertainty in PWS data, but also a lot of value. And this is a few images from a very nice study from Simon Bell in 2015, showing that different PWSs have a lot of radiation errors, and where you see that the WS2350, which is the one in the middle, has over 6 degrees of error because of the radiation shielding, or if it's directly in the sun. And similarly for rainfall observations, of course, if your station is located incorrectly, if it's blocked, or if it's underneath a tree, or if it's not cleaned at all, you'll also get severe errors. And usually we just have to deal with that in our data quality controls. But maybe if we know something about these citizen scientists and their setup, we can infer from errors in the data how the station might be set up incorrectly. Can we quantify the effect of bad setup? Because as scientists, as meteorologists, as hydrologists, we always assume like an ideal installation. We know how to install a station. We know how it should be installed. And people want to install their station correctly, of course, but it's not always possible. I'll show a couple of photos later from actual gardens in Delft and their stations. And you will see that even these citizen scientists that get extra instructions from us simply just cannot always place their station in the right way. So what is the effect of the station installation on the observed rainfall of this particular PWS? But also what hindrances, what blocks people basically to install their station in the way that we would like? Is it just difficult? Is it personal choice? So we had a couple of research questions in Marchien's thesis. Again, first, of course, looking at the hardware itself, how good is the station itself if you do install it correctly? For that, we set up 8 of these stations at our outdoor field lab on the TU campus, the Green Village, to see if we set it up correctly, how accurate is it, and then if we deliberately misinstall it, like tilt it or block it, what do we then see in the data, knowing that we installed it the way we wanted to? But also the people side of things. How does monitoring and maintenance of the owners, so how often do they check their data, how often do they check their station, how would that influence data quality? So this is a nice artist's impression of the urban outdoor field lab that we have here on campus, the Green Village, which has actual people living in it. And we basically monitor the whole place, indoor and outdoor, focusing on climate and energy and the built environment. So it's a great place to test things like this in a semi-controlled urban environment without having to actually put your measurement equipment in a city where it could get stolen and so on. So this is the experimental setup that we have. The picture is a bit small, but I will take you through it. So we have an idealized setup that you see here on the left, those 3 stations next to each other to make sure that they should be measuring the same thing. They are installed level at the same height, so you would expect the same data. At the end of Marchien's thesis, we tilted one of these stations, number 3, so that's the one closest to me, basically. To see, okay, what if we give that an extreme tilt? We also tilted another one that was also installed on a different place, slightly. We have one on top of the roof of an office building, and because then your wind effects, your turbulence will be different than the ones that are very close to the ground. There is a station next to one of the walls of one of the houses. There is one in an open field and one near a tree. And we have a whole bunch of reference data as well. So we have, of course, the KNMI radar. There is a manual rain gauge nearby, which you also use for the daily data. We have a micro rain radar installed near those 3 stations, as well as the Davidge Vantage Pro 2, which is, of course, a bit more high-end station. Though you will see later on that maybe that does not mean much. This is an example of the blocked station, and this is well, a pretty real situation, because when we installed it on the right, this lavender plant was not flowering yet. So we did not expect it to actually basically grow into the station. And then, of course, that caused extra hindrance. But we did not cut it because this might happen in people's gardens as well. And we could actually see a tilt in the observed data there. The bias turned out different after this plant started basically growing into the station, which was pretty interesting to see, that there was basically a growing season for your rain measurements as well. So very quickly, the Alecto has a single tipping bucket, and the NetAtmo has a double one, which means it tilts in a singular direction, which means that it's also quite sensitive to errors in this tipping volume, because it could tip incompletely or too quickly. If it's tilted in the direction of the tilt, it will tip too quickly, so it's not fully full when it tips, which overestimates your rainfall. But you also see that it doesn't completely empty all the time, but it's more design, honestly. So then it fills up quicker and it also tips quicker as well. So pretty easy to make an error in this, aside from the other errors we see in every single rain gauge and every blocking of the funnel and filling up with leaves and so on and so on. So a quick comparison basically between the Alecto, which is the thick black line, and all of the reference data that I just mentioned. So the KNMI daily gauge and the radar in green, the micro rain radar in the dashed black line, and the Davidge Ventus Pro stations. There's two of them, one of which actually suffered a power outage and did not work after September, unfortunately. And the other one that was on top of the office building over there. And you actually already see that even between all of these reference data that we should trust, there is a pretty big difference. We do actually think that this Davidge station was not installed correctly because it really did not catch this big precipitation event that you see outlined. And the Alecto, while it's not perfect, it shows pretty good correlation with the radar data, especially, and with the rain gauge nearby. So overall, we're quite confident. We, of course, also applied some quality control in this data, bias corrections, outlier filters, and so on. That's not really the point of this talk, but know that we did apply these based on the method of Lotte de Vos. And what is interesting is to look at this bias in the data. Can we link that to where it was placed? So the station number on the bottom versus the relative bias of the uncorrected data on the vertical axis. Whereas you see that number 3, which was and 4 are the tilted ones. 3 was tilted pretty extremely, and 4 only slightly. Then station number 5, pretty interesting. That was the lavender one, basically. So it was next to a wall and also basically in a plant. So it got, after all of this correction, still a bias of minus 11%. And the stations on the rooftop actually seemed to be the most okay. And then station number 8 was basically in a sort of a free field. So it would be the least urban one out of all of them. So it's also the least blocked, which means that it would get a little bit more precipitation. So the most interesting ones are really the tilted one and the wall one, also because those you would expect to see relatively often in real data of the citizen science crowdsourced stations that we see in the field. So that's basically what I just said, honestly. But we also saw that the data transfer sometimes caused issues because the sampling of these stations is almost 5 minutes, but not exactly, which means that if you then start comparing 5-minute intervals, you might be a little bit off. So that's more a data aggregation thing than really a quality thing. But it says something about the transfer of the data as well. But it's, of course, not only about the data itself, but more about how do we connect this to the people. So this is a flyer in Dutch, of course, that we share with all of our participants, and also that we put out if you want more, to make it relevant to the people. What's in it for them? Why is it important? Why do we need to research this? To really get the citizen science part on board as well. So not only data for us, but also meaningful dialogue and giving the data back basically to the citizens. We have a lot of interactions with them. We have sort of these information meetings every 4 or 5 months, where we also ask them if they are interested in other things that we can then research. And if we have the students or a PhD student perhaps to put on this research, we can also research their own interests. And that is how this project has been successfully running for almost 5 years now, instead of just getting data and then not giving back. So we also gave them a survey in 2023, asking them how often do you maintain your station? How often do you have a look at the data? Is your station still going? We even visited them at their home sometimes to assist with the installation, which can be a bit complex, especially linking to the WOW platform that the data is on from the UK Met Office. And here you see something. So there's a creepy crawly in the bottom one. I think it's a worm which blocks the funnel of your rain gauge. And in the upper one, the tipping bucket is getting dirty and therefore filled up with junk and will then also tip faster, of course. So we would be thinking probably if the station is not well maintained, the bias might be higher. As well as we, of course, asked them, like, where is your station actually installed? So we got a whole bunch of photographs from them, which showed us a big variation in setup and bias. And of course, these people will have been asked to install their station correctly, but they can't always do that. You can't put it in the middle of your garden if your garden is very small. So here are a couple of images. I especially invite you to solve the puzzle of the top right one. Where is the station? It is well, difficult to find. And you see that there is there's several of these very close to walls. There's a bunch that are just like our setup, basically inside those plants, which means that the research that we did on the Green Village could really help us in trying to quantify the bias in these data, and also try to reverse engineer it. If we have another data set where we don't have this citizen interaction, but we do see a certain type of bias, we can perhaps identify how the station would be installed and deal with that accordingly. So some quick plots of the survey results, where basically the darker the color is, the less often they do this, and this is maintenance. So from left to right, it's check if the station is level. So if it's level, of course, you want that, because otherwise you'll have tipping bucket errors. Check if the funnel is blocked. Most people do those two things. Check if the tipping bucket itself is blocked, and you see that happening less often, because then you need to unscrew the funnel of the station, so it's a bit more work. Cleaning the outside and cleaning the buckets themselves. So the outside of the station, not so much the tipping bucket. People do actually clean that. We could not really identify a clear, significant relationship, however, between these sort of the maintenance frequency and the bias combined with what we knew about the setup. Probably because all of these things are happening at the same time. They don't happen in isolation. So for follow-up research, for us, it might be interesting to have at least 3 different stations that are installed the same way to vary the maintenance. So clean one very regularly and one not at all, and one in the middle, to see if we can then, after some time, do see a bias in this. But in the real data, there's so many effects happening at once that it was quite difficult to see. People do like to check their own data, of course, daily, and just looking at, hey, is it how much rain did I get? So that's really nice. These people are super motivated, very interested to work. Not so much at the website, and also less of their neighboring stations, even though for data quality control, we of course always look at nearest neighbor data as well. And the check at the WOW website is pretty crucial, because that if data is not there, it could mean that your station is out and it's not sending data anymore, which you can then still see on your indoor monitor, but not on the website, which is really unfortunate, because then we can't use it. So in conclusion, there's a lot of variations in these bias for the different station, owing to the different station setups and the frequency, which makes it difficult to disentangle all of these different effects happening at once, but they are there. And so we do see significant differences. It's just hard to attribute it to what it is. So there is quite a bit of value in this, but it really needs a longer setup, follow-up research on our end as well. So for a take-home message, not really a conclusion, but this project is still ongoing, and it's really a well-functioning citizen science project. Takes effort, of course, but I think it's quite valuable to correct our data, but also for citizens to remain or foster interest in science and participate in it, which I think in this political climate that we're in right now is pretty important, to show that we also are doing things for them, to get them interested in the local climate, in climate adaptation, what they can do for themselves. So looking ahead would be great to estimate station setup, and therefore how do we correct for this based just from the data, but we're not quite there yet. We basically need more isolated examples to really feed into this. And we have a student that might be interested in this. So this is ongoing, just as the project itself, trying to get larger data sets, and also for people to be more even readily accessible to address these issues with the data processing. And thank you for your attention. If you have any questions, please let me know.
Yeah, thank you, Arjan, for this very interesting presentation on the studies you did. If there are questions, we have time for a few questions. Yeah, it's the question from Louis.
Yes. Thanks for the interesting talk. I was wondering about the recruitment of the citizen. If you could explain a bit more, like which kind of people are interested in contributing to this?
Yeah, so there is kind of a bias of people that apply to it, and I tend to describe them as basically my parents. So retired and living in suburbs, usually with an interest in this sort of kind of thing. But we have really tried to recruit more people, like the more, well, not the usual suspects, basically. Also, really looking at the city center of Delft, for instance, where you would have some more young people, also lower income, perhaps. But there is, of course, a certain kind of person that's already interested in science, interested in contributing, has a large garden, and therefore would like a station like this. But last year we had another 10 stations added to the project, and we had like 90 applicants for this. So it's also really living in the community. People are interested in it, and we do advertisement a little bit in the local newspaper and some social media and so on. But yeah, there is a certain type of person that comes to to mind, basically.
Yeah, thank you. There are two other questions. The first one was Martin, I think.
Yes, thank you for the nice talk. I have a question about the station. Why did you choose exactly this type of station? Was there a kind of survey on beforehand to see what station was the best for your project?
Yeah, this was actually this was chosen by people before I arrived in Delft, but they told me that this was done both on the coasts, of course, and this is a pretty cheap station, €200, so that is affordable for our project. We donate these to the citizens, by the way. They don't buy them themselves; we give them to them, so we need some money for this. The fact that it measures all of these different things in one single setup, unlike the NetAtmo, for instance, which has a different rain module and a different wind module and a different temperature module. This is just a single thing that you install. And it was also, there was some communication with the KNMI, the Dutch Met Office, to ask them, hey, we have these different stations, which one would be the best basically to install? Which is also based on the fact that this one has a built-in radiation screen for the temperature sensor, for instance. So the price quality sort of balance of this particular station seemed to be the best. And it's working pretty well. It's also fairly sturdy. There's no station outages yet. So we'll have to see what the lifetime of the station is. But it's pretty robust so far. So.
Okay, thanks.
So the next question is from Hannes.
Hey, yeah, thank you. Thank you for the nice talk. On one slide, you were showing the bias related to the location where the rain gauge is installed, and I was wondering if you have any further investigations on that, depending on the wind velocity, because this would have here a high effect. So is this on your list to do, or?
It's definitely on the list. Yeah, I believe the student did not look at it back then, but it's definitely, yeah, especially the one near the wall, for instance. It is the wall is on the south of the station, and the wind direction here is mainly southwest, which means that you have a very sheltered effect, basically. Whereas if you would have winds from the north, you would probably not see this bias at all. So yeah, that's definitely a good point. And also quite relevant, since your wind direction in your urban canyon or in your garden where the station is installed might be really different from the prevailing wind direction, basically, because it's either cross canyon or perpendicular to it. So that's definitely an interesting thing to install, to investigate for sure. Yeah.
Thanks.
And it's the question from George as well.
Yes, thank you for the nice talk. It's really interesting. I wanted to see if, I don't know if in Delft this exists, but I suppose it does. In Luxembourg, we have a lot of activities going on in urban gardening. And so if people don't have their own space because they're in an urban area, but if you have something like an urban gardening, you could install this kind of stations and maintain it as a group, so that not one single person is then responsible for that, but that a group of people would be responsible for cleaning it or whatever is needed for maintenance and so on. Do you have experience on that?
Well, we do have those urban gardens like that in Delft as well, and that's actually a really good point. I had not considered this. So we do have one at a petting zoo, so a miniature zoo basically for kids, but that's just maintained by the staff of this petting zoo. We also have one at a sports field where it's maintained by the one of the sport clubs basically. So then there's also multiple people in charge. But the urban communal garden thing, that's definitely interesting because it's also again a type of person that might be interested in it. They tend to be a bit more on the edges of town as well, where we don't always have the data. So it's a good suggestion. Thank you.
Okay, great. So thank you for your presentation once again and for this very interesting discussion. Now it's the time for our second speaker. Bas, could you introduce him?
Yes, so our second speaker is actually the last one who asked the question. Is George Schutz, who will present on a toolbox for real-time data acquisition of personal weather station rainfall data. And Dr. Schutz is one of the founders of RTC for Water in Luxembourg. He spent the last decades dedicated to solving problems in water management, and then specifically the modeling and model-based control of the dynamic systems. He holds a doctorate in information informatics and has been heavily involved as well in the predictive control research topics. And prior to funding RTC for Water, Dr. Schutz was a lead researcher at Luxembourg Institute of Science and Technology. So very curious what George has to say, and I would like to give you the floor. Thank you.
Thank you for the introduction. First I want to say that the talk or what I'm going to present is not done only by me. It was a result of a short scientific mission together with Jochen Seidel and Natalia Rombeck. Jochen from Stuttgart and Natalia from Delft. So we have heavy Delft involvement here, I think. And so it was an SDSM, and it was done in February this year, and it was snowing. And the photo I just put was the way to go to the university each morning for me. And it was super nice. It was cold, but it was super nice. So what was the motivation of doing this SDSM and also this work is that, of course, everybody knows there's data available on official stations, but there is a lot more data available on this kind of personal weather stations. And we have a very high temporal and also spatial resolution that we can have. So we get more detailed data. And the idea here was, or the motivation here was for flood forecasting, especially, or real-time control of sewer systems. And so the focus was really on getting this data in real time and focusing on what are the issues when you want to get this in real time. The density is high, but also some of these stations are not, the official stations are first not so dense and often also not necessarily available in near real time. You can get them as archived data, or maybe an hour later, you will already have the data of the last hour, but often not in near real time for an application that would be like flood forecasting or real-time control. Then you have, of course, weather radars that exist, but they have different other kind of sources. And also, when you start to correct this data, you have the same problem because you need then the gauges available to be able to correct them. And so this gives you all kind of latency if you look at real-time aspects. And there's another element that is interesting for these personal weather stations, because often these platforms are not country specific, so they go cross-border regional areas they look at. So it's also that is a quite interesting element in that. So we focused on this short-term scientific mission mainly on these NetAtmo personal weather stations, because first they are mainly what you find in a lot of places, or at least in Europe, it is very, very broadly used, and they are really low cost. And of course, we know all these issues that you already talked in the previous talk of these errors that come. I will also give you some examples on this. The range of this kind of personal weather station, as we saw in the previous talk, also is really large. So you get semi-professional stations also as personal weather stations. Then, of course, the investment is a bit higher most of the time, but it depends a bit on what your aim is. The number is extremely larger than what you get as national official stations. So we tried to, when we were in Stuttgart, to sense the stations available in the greater region of Stuttgart, and you get something like 1,800 stations around Stuttgart. I mean, you will have maybe 5 or 10 official stations in that area. So, I mean, this is just a huge number difference that you have. And also from the resolution, of course, it is very different. And of course, there is this not correctly installed. We had view on this. The setup of these personal weather stations, and I think that is really a good idea to get this more in contact with the citizen scientists to lead the people to install the stations in a way that it makes sense for them, but also for other usage afterwards. There is also another network like that in Italy, where we were in Italy for the last conference. We were in contact with them, so it's quite interesting. They also are focused on citizen sciences and have an online platform, but we were not able in the short scientific mission, it was just a week, to have a look at all these details and in which way we could access data in real time for this kind of station. What was also very interesting that is we looked at the quality control methods and in which way they would be applicable to in real time. So not on an archive data, but in the real time approach. So just for an idea, if you there's different ways you can use to scan what kind of station are available. One is just going to the NetAtmo weather map and scan, so like doing web scrolling, scan the stations that are visible on the web page. What you need to know with at least the NetAtmo stations is that depending on your zoom level on the site, you get more or less stations that pop up or show up. So it's really important to have an idea of if you want to get a lot of these stations and not always different ones to get to go to more details to how to get these stations that are available. There we tested another approach that is the support of this API that is supported by NetAtmo. So NetAtmo provides an API that is usable also in Python. So we used the Python environment for doing that, where you can first scan what stations do exist. And also there, it is important to know that the size of the area that you are scanning depends on the result that you're getting. And here I'm just having a short image on how we did this. So you have like the big gray area that's a bit darker. That was our like bounding box. We wanted to scan stations in, and then we just put tails, smaller tails, and we went over the whole area to find all the stations that are in there, because otherwise if you do it in one go for the whole bounding box, you will not get all the stations. You will just get a part of it. And each time if you request via the API the stations, you will get different ones. So of course, what you could also do is just rescan and try to identify which ones are popping up new, and then you put them in the list, or you do it via the way we tried it with some smaller tails that are just scanning all the bounding box that you want. Then of course this API, we also use it to download archive data, to have a look at data, but also to download in real time some of this data. What is one of the issues in real time is that, like we heard before, so the temporary resolution in principle is 5 minutes of this data. but you have this kind of tipping. So NetAtmo has this double tipping buckets, but you don't know at which moment in the 5 minutes the tips take place. So you only know the total number of tips during these 5 minutes. This is not necessarily an issue. If you look at, I don't know, like daily data, you don't care. But if you look at real-time approach, then you may be interested in the more details. And so the other aspect here is that the update cycle of the data is not 5 minutes. So you get the new data more or less each 10 minutes, which means that you have an more or less irregular time latency. So each time in these 10 minutes, you may get 0 up to 2 data sets that are new in the period that you just, when you request, get the data. So you're not sure to get a new data point each time. You may just lose it. And in the table below, you get a bit of an idea. There's 2 personal weather stations that, as an example, and then you get at which moment the I just went too far. At which moment the tipping or the data is available at the station. So if you scan with the very high resolution, we tried that. So scanning with like a 30-second or 10-second resolution, then you get the moment in which the data comes up. And so you see, okay, that's the time moment when this new data is available. And when you then do a resampling, one of the issues, or you use the resampling that NetAtmo provides itself, you will get issues that some of these tips are just in the wrong, wrongly attributed. It depends always if your real-time resolution needs to be super high or not, and what your application behind is, if this is an issue or if it is not an issue. But you should just be aware that if you do this resampling, that sometimes you don't really exactly know when these tips took place. Also here, and I mean, people that work with this kind of data probably know this, but this here is an example of like faulty zeros and high influx issues that you see in this kind of data. So the blue lines are the blue points are the data that are effectively available on this coming in when you request the data. And you see that for a certain period, there's just no data coming in. And then you have a big peak. And this comes from the fact that this probably, we don't know exactly, but it's probably the effect that the device that is not connected to the main station just get these tips and it is accumulating the tips. And when then the connection comes up again to the main station from the device, then it is just reporting all the accumulated tips in that period. And that's why you get like a high peak. But that was probably distributed on the not communicating period previously. And you also have, like where I said, this jittering sampling. So you don't have like a 5-minute resolution. You can have 2 minutes, 1 minute, or it can be 6 or 7 minutes. So it's not super regular, and it really depends on I would say it mainly depends probably on the communication between the device and the main station that you have. Because you see that there's periods where this works perfectly and there's periods where it just doesn't work really well. And I personally think that it is the reason of this is Wi-Fi connectivity. Because these devices are connected via Wi-Fi to the main station of NetAtmo. And so, of course, Wi-Fi, we know that in rainy periods, OpenSense is about that the signal is attenuated. And so it just may be that such stations are a bit too far away for the situation, the rainy situation, and that's the Wi-Fi just not connecting up, and it will connect just a little bit later, and then you get this kind of strange or not regular information. Then if you, we have this situation where we get each 10 minutes like new information, but we may get 1, 2, or 0 inputs. And so I just made an example here of, because the number of stations you have, if I would request the stations in 2.5 minutes each time. So getting a time resolution of 2.5 minutes, although the individual stations have only like 5 minutes or 10 minutes latency information, you could, via all these stations, still get quite a high 2.5 minutes resolution in real time, because the green X's are the data that is reported at that moment when you request. And so you would get at 10, 0 to 30 seconds, you would get 4 stations where you have new data, and the 10th station will have the say old data, but that is not available at that moment in time. And also the first station would be the same situation. So then you would go the next 2.5 minutes on, you would only get 1 new data point. The next one you get 2 new data points, and so on. So, but you would be able, if you have like thousands of stations, still get a very good coverage, even in a higher temporal resolution, when looking at this kind of approach, where you get the data in and you use them diversely in a higher resolution. That was an idea that we came up, and it's also in the process of implementing like an Python environment to get this data in this kind of approach. But there's some limitations on that, because NetAtmo limits your request per user to 500 requests per hour. So you cannot do more than 500 requests per hour. This means that if you only look at rain data, so if you don't look at devices like temperature, wind direction, whatever, because each of these devices, if you request data as an individual request, then you would have, say, considering 10 minutes of update period, more or less, you would have in 500 requests that you can do. In 1 hour, you can divide 1 hour by 10 minutes, so you get 6 data points. So you could scan 83 stations on real time. That would be the limit for one single user. Of course, you can tweak with multiple users and handle this in a way you can get very innovative here if you want. But this is what is the restriction to get in real-time data from NetAtmo stations fails unofficially. But NetAtmo in itself also provides you with something that is called push service. And the first one that we identified was that the Met Service of Norway used this in 2022. We are not really sure if this is still the case, so if they have still this service going on. But there, the approach was that NetAtmo sends them in asynchronous way JSON files with the latest data, and then they assimilate the data more or less in a real-time approach. Now, today, there is, or today, in the closest future, so starting in July 2025, there is the UMetNet that is having a contract with NetAtmo for 6 months during the summer period, where they get in real-time data for the more or less 300,000 personal weather stations that are on NetAtmo, and they are putting this information to all the partners of the UMetNet. Exactly how this data is going to show up and look like, we don't yet know. We have contact with some of the German Met Service, for example, that will get access to this data. And it would be really interesting to see in which way and what real-time criteria this kind of push service would have. They also have some quality control included, apparently, in this personal weather station data that comes from them. And we know that Météo France is doing currently work on real-time quality control for personal weather stations that are not only NetAtmo, but also other kind of personal weather stations. There's also a lot of work done on quality control, and we try to identify which kind of approaches would fit real-time. And so the methodologies that are out there on false D zeros or high influx filtering would, with small changes, be able to be applicable on real time. We are working on that currently. So the team that was on this short scientific mission is working on this on the code base to develop some Python around that. We also think that indicator correlation, of course, as is, it cannot be applied easily to real time because it needs just some archive data or some longer data series to be applicable. But we think that there is, with some modifications, possibility to also profit from principle of this kind of approach in real-time quality control. But we need to see a little bit what the French Meteo does, in which way this is applicable. This is apparently also published afterwards when they are finished. So we will get access to this methodology that will be developed. Yeah, so the problem that we see is that some of these personal weather stations may just have very specific issues at the given moment in time. So one of the approach of faulty zeros high influx is that if you identify a station, you just kick it out if it has too much of these errors. But you may then lose a lot of these stations if you do this. And so the idea here was to see, okay, can we identify at which moment in time these kind of stations would have issues, and then just take them out for a short period and re-evaluate the data in a real-time approach, and to be able to say, okay, we take this station temporarily in again to check if this is valuable or not. And if it is not, then it's more like a real-time kicking in or putting out stations depending on their data. So you could also flag stations with reliability of this kind of stations, and of course also link to the citizen science approach. When you know that there's people behind it that are really very into this and they try to do everything that is feasible to get really good supporting data, it would be also interesting to take this into account in the ranking of this kind of personal weather stations. More on this, so future work and outlook, more on this is going to be presented at the OpenSense conference in July in Germany. And also we are working on a Python platform for quality control, but also for to make a user-friendly API for accessing these personal weather stations in real time. Then that's the Meteo Italian, so this citizen science platform in Italy, that would be also interesting. They also have an API, but we did not have time yet to analyze this more in details. Yes, this was everything from my side. I hope there's some people that have some questions about this, but yes, thank you.
Thank you, George, for this detailed presentation on the real-time PWS opportunities and limitations. Are there any questions to George?
Maybe I can ask a question. Thanks, George. And I'm trying to link the first presentation to the second one. Of course, at the scale that you are using the NetAtmos station, it's impossible to do the same type of work that has been done by Arjan and his team. But do you see, ways to combine not only because you talked about it depends on who the person installing, but as we saw in Arjan's presentation, sometimes the person can be an expert maybe, but he or she doesn't have the place or the room to install it correctly. Are there, for example, such flags around installation in the NetAtmos PWS data that you can use?
No, there's no real information on where these stations are. I mean, there's like geolocation on the point, but this is often can also be completely wrong because people put this manually in. It is not like an how do you like geolocated automatic thing. So you need to put the geo references in, and this sometimes is just wrongly done. And there are also some places that are just like default places if people don't put anything in. And you also see this, some of these stations are just all on the same place because people did not put the geolocation correctly in, and then they are all located in the default place. So this kind of stuff is existing, yes, and it is of course an issue, and you don't know which people these are. I mean, this is not a citizen science project, so you don't have a connection to these people and also no way to really get to them. But what I think is still feasible is that if you, so what we are planning to do in Luxembourg is that we are working with the utilities that are in the sewer system that have this different kind of what is CSO structures to put like NetAtmo stations on their plant and also do the maintenance by themselves because it's not a big investment and it would just increase the availability of information in a really large way. And it would be like a professional use of this kind of station. And then, of course, you have knowledge of which person is this, who is maintaining that, and so on. And then you would have, and you could, of course, do this also with a citizen science project, the way it was presented in the previous talk. I also thought about another element with relinking to the citizen science is that, I mean, this kind of real-time online analysis could also trigger some alerting or alarming towards the citizen that manage a structure. Say, if you have this connection, you could just automatically quality control data and see if there's a station out of bound, biased, whatever, changing properties over time, and then get like an information back to the person so that he can have a dedicated look at the moment where, and not just regularly do maintenance, which costs a lot of time, but just do it if there is a need.
Yeah, yeah, very interesting. Yeah, thanks.
There's another question from Arjan.
Yeah, not so much even a question, but I'd like to react to that because I think that's a great idea. It's currently we have someone that also just checks the data that's coming in, basically, but we do that manually. So if we have this sort of automated thing, even especially in real time, but even if it wasn't in real time, it would already be great. It can also help the citizen scientists detect problems with their stations much quicker than we can or they can themselves, especially since they themselves don't often check the data. So I think that would be a very nice way to do this.
Yeah, but I think that in this kind of context, you have contact to them, so you can somehow give them a feedback of some automatic thing. And so this is, I mean, in the NetAtmo situation, it is not feasible because you don't know who these people are. You don't have any connection. But in such a project, you would have, and I think this is would be a valuable element.
Absolutely, I agree.
There are also two other comments from Remco, who is greeting us from the train to Delft. He wrote it in the chat. So the first one is to George. Thanks, George. Nice work. It would be great if you would convince NetAtmo to store and share the tipping times instead of the numbers of tips per interval. In terms of data storage, that would be also efficient. You only store tipping times if it rains and not when it is dry. Greetings from the train to Delft. So it's the first
agree.
comment.
Yeah, completely agree with that. I'm not really sure. Maybe OpenSense as a project could contact NetAtmo, or maybe via this MeteorNet. So because they have already this connection now with NetAtmo, maybe they can propose something. We need to discuss this maybe on the conference in July, just to see in which way we could coordinate this. Because I mean, if I connect NetAtmo, nobody's caring.
Yes, that's a nice suggestion. And also the second comment from Remco is actually a question to Arjan. Could you tell us a bit more about other variables that Delft Meet is collecting beyond rainfall, perhaps a link to Emil's recently started PhD work?
Yes, well, he is involved in PhD supervision, so he knows. But it's well to share that with you. Yeah, so it's, those stations that I mentioned, they don't measure just rainfall. They also measure temperature and humidity. And we have a PhD, Emil, who started in February, looking at especially the relative humidity variations in the urban environment, which is, of course, can be very variable and relates to heat stress. And also, we would like to link that to for instance, how a garden or the personal environment of a citizen scientist is built up. If you have a very green garden, you would expect less heat stress, but perhaps the relative humidity would be higher, which would then again increase your heat stress. So looking at that is also what we try to use these stations for, to really link it to the thermal microclimate as well, not just rainfall, which well goes for every single PWS station basically, net atmos similar. So.
Yeah, amazing. Good to see that this work is ongoing. From the OpenSense side, I would like to remind you about the conference, which is in June. It's 25th, 26th of June, the first international conference on opportunistic sensing of precipitation. And the timetable for this conference is already available at our conference webpage. So it would be good if you will have a look there. The registration is still open. So in case some of you are not registered yet, you can still do so. And also another comment is that that our next conference, short online conference in July will be on 29th of July, as usually at 9 o'clock. And so I hope that you will follow our news on the webpage to see who will be our next speaker. So that's for today, everything from our side. Thanks once again to our speakers and to all of you for the participation. Thank you very much.
Thank you.
Thank you all.
Thank you very much. Bye-bye.
Thank you.
Thank you. Bye-bye.
Bye.
Thanks. Bye-bye.